Right, this is one of the example for question in calculating using lever rule. Okay, the question is calculate the amounts of solid and liquid at the temperature is given here 1250 degrees Celsius in the copper 35% nickel alloy. Alright, this is the question. Okay, first what do is we have to plot the point of interest here. So it states that at 1250 degrees Celsius, so it is around here, and at 35 weight percentage of copper nickel alloy, so it's around here, right? And with 35. Okay, at 35. Around here. Okay, so this is 35, this is 1250 degrees Celsius. Alright, so first we have to plot it. So we can see that it is in two-phase region where it has solid denotes by alpha plus liquid there. This is a two-phase region. So how do we know the amount of the each phases present there? How much is solid and how much is liquid in that two-phase region? So what we do now is we have to draw a tie line. Draw a tie line. What is tie line? Tie line is a horizontal line passing through the point of interest here. Okay. At same temperature, connecting the solidus line. This is the solidus line, and connecting the liquidus line. If we project, we draw first. So we will draw the tie line here. Okay, this is the tie line connecting the solidus line and connecting the liquidus line. So this is our tie line. It is a horizontal line at the same temperature. So after that, we will project one end of tie line down on x-axis so that we can know the CL and also C alpha. Okay, we project it down using different color. Okay, from the liquidus line, we can know. We project it down first. So from the liquidus line here, we will get the CL. And from the solidus line here, we will get the C alpha. Okay, this is the C alpha. Okay, when we project down, we will get that. Okay. So now what we will do is we find the relative amount of WL and W alpha. Okay. So here we can get that the CL is around 31 point, when C naught just now is 35 weight%, right? Okay. Okay, CL here we get around 31.5 weight%. And the C alpha we get, if you draw it in a scale diagram, you can have this reading. C alpha is 42.5 weight%. Okay, in order for us to know how much solid and how much liquid is present there in this two-phase region, since we already know the composition here, okay, we will calculate it using the formula that we have learned in derivation of level rule just now. So W alpha is, okay, what color we will use here? All right, fraction of alpha equals to, okay, let's take a look at this one. Is our CO, this one is our CL, okay, this one is our CL, this one is our CO, and this one is our C alpha. So weight fraction of solid is the CO minus CL here. CO minus CL here. We will take the opposite. Okay, when we want to take fraction of solid, we will take the opposite line, which is the CO to CL here. So CO minus CL divide by the entire line here, which is C alpha minus CL. And we get 35 minus 31.5 divide by 42.5, 31.5. So here we get the fraction of solid is 31.8%. What about fraction of liquid? We already know that fraction of solid plus fraction of liquid is equals to 1. Okay, so in percentage, the fraction of liquid is 100% minus 31.8%, we get 68.2%. This is the fraction of solid. So how much solid is present in this point of interest? It is 31.8% solid and 68.2% liquid at the composition of 35 weight% of nickel in copper nickel alloy. All right. So to summarize what we get, the steps in order for us to get the weight% of solid and liquid here. So we have 5 steps here. All right, the 5 steps that is very important. 5 steps of level rule. So first is to draw find the phase present. Okay, sorry here. First is we have to find the phase present. Okay, so at this point of interest, we have phase of solid solution and also liquid. Okay, the second step is to find the composition. To know, in order to know the Cl and C alpha, by knowing the C naught. Okay, we already, C naught is given just now. C naught is given in the question. So from C naught we draw a horizontal line. Draw a tie line here from C naught. Okay, draw a tie line from C naught to liquidus line and to and solidus line. Okay, the third step will be we have to find the relative amount WL and W, fraction of solid and fraction of liquid. Okay, from the formula. And 4, we will find the microstructure that occurs in that region. And 5, we will find cooling curve if necessary. Okay. So step 4 and 5 we will discuss in the next video.